Today we're going to solve systems of equations by using what's called a method of substitution. It's going to be important for us to know how to solve systems algebraically because sometimes where the points cross, where the lines cross with each other, that intersection has coordinates like decimals or fractions, and it's really hard for us to understand. That's why it's important to know how to do this algebraically. So let's take a look at this example. We have 2x minus y equals 5 and x plus y equals 4. We have two equations and they're in two variables. So our goal is to get a solution that will satisfy both of these. When you have two variables like that, we're going to want to solve one equation for y. Substitute that value into the other equation and then simplify to get the value of x. Then we use that value of x in one of the equations to get y. Just watch as we do this one together. We have the two equations, 2x minus y equals 5 and x plus y equals 4. Both of these equations are in the standard form. If you put one of them into y-intercept form by solving for y, you have a value for y in terms of x. Let's just do the second one because it really doesn't have any coefficients and it'll be super easy to do. So we're going to solve this equation, x plus y equals 4, for y. That means we're getting y all by itself. When you subtract x from both sides, you'll get y equals negative x plus 4. Now that we know what y equals, negative x plus 4, we can plug this value into our equation for y. So plug in parentheses where you have your y, and in those parentheses we'll put negative x plus 4. Now we can simplify this. 2x minus the quantity negative x plus 4 equals 5. Distribute our negative into the parentheses to get 2x plus x minus 4 equals 5. Combine like terms. 2x plus x is 3x. Subtract 4 from both sides to get 3x equals 9. And divide both sides by 3 to get x equals 3. Now that we know what x is, we can take this value and plug it in to our second equation. Y equals negative x plus 4. When I plug this in, I'll have y equals negative 3 plus 4, and that shows me that y equals 1. This gives me my solution. X is 3, y is 1, so the point where our lines intersect is 3, 1. Don't forget that you can check this to see if you're right. 3, 1 will satisfy both equations and make it true. Let's do example 1 together. In this example, we have 4x plus 6y equals 34 and x plus y equals 7. We want to choose one of these equations and solve for y. Let's do the second one because y is almost by itself. All we have to do is move the x. So for us to get y all by itself on one side of the equal sign, we need to move away from it the x. And we'll do so by subtracting x from both sides. When we subtract x from both sides, y will equal negative x plus 7. So we have this equation in slope-intercept form. So let's take our value of y, which is negative x plus 7, and plug it in for y into our first equation. So 4x plus 6, inside my parentheses for y, I can put this value, negative x plus 7. Now we can solve for x. First thing we need to do is distribute the 6 into our parentheses. That will give us 4x minus 6x plus 42 equals 34. Combine like terms. Our like terms are 4x and negative 6x. When I combine these like terms, I'll have negative 2x plus 42 equals 34. Subtract 42 from both sides to have negative 2x equals negative 8. And finally, divide both sides by negative 2, so x equals 4. Now that we know what x equals, we can plug this back in for y. So we'll plug in y equals negative x plus 7. And our value for x is 4. So y equals 3. My x is 4. My y is 3. So the point where my lines intersect is at 4, 3. Don't forget you can also CK check and plug this value in for x and y, and you'll see that it's true for both equations. So you are correct. Take a look at example 2. Given the two equations below, what are the coordinates of the intersection? Y equals 2x plus 4 and y equals 1/2 x minus 2. Since both equations are in slope-intercept form, you can solve this one a little differently. We have this rule in algebra that says if a equals c and b equals c, then a will equal b. Both right-sided expressions are equal to y. That makes them equal to each other. So let's set them up equal to each other. 2x plus 4 is equal to 1/2 x minus 2. All we need to do is solve for x. Since I have this fraction, let's get rid of the fraction by multiplying by the least common denominator, which is 2. This gives me 4x plus 8 equals x minus 4. Solve for x by subtracting x from both sides to get 3x plus 8 equals negative 4. Subtract 8 from both sides, so 3x equals negative 12. And when you divide both sides by 3, x will equal negative 4. Now that we know what x equals, we can plug in x into one of these equations. Let's do the first one, y equals 2x plus 4. And I'll plug in my value of x, which we just solved, and found out that it was negative 4. So y equals negative 8 plus 4, and negative 8 plus 4 is negative 4. So our ordered pair is negative 4, negative 4. That's where our lines will intersect. Try the practice problems. Use substitution to find the point of intersection for each system of equations. Write your answer in the blank as an ordered pair. Don't forget to check your work. Press pause. When you're ready to continue and check your answers, press play. Check your answers.